right, welcome back, everybody, for anybody who's watching along at home. So, again, like I have been saying to my in-class students here, remember that the fourth 9 weeks is extremely important. If you fail the fourth 9 weeks, then you fail the final exam, you fail the course for the year, no matter what. Those of you with a failing grade right now, it's extremely important that you bring your grade up. Okay? It's extremely important. You don't want to have to bank on the final exam, because guess what? The final exam is going to be difficult. Any exam is difficult. Okay? Any exam is difficult. Am I going to give you the review assignments to go along with the exam? Of course I am. Am I going to prepare you for it? Of course I am. But those of you, if you did not prepare for any of the quizzes and tests, and then you fail the quizzes and tests, the trajectory is that you might not prepare for the exam, and then you might fail the exam as well. So be careful. Just be careful. I would hate to see you over through the window in Mrs. Napolz's class next year. Okay? Don't want to do that. All right. So let's talk about the push to, and we don't need to be doing anything on our computers right now. Okay? So there's no keys should be clicking. You don't have to put them away. We will use them in like a second. Just you don't have to be typing anything or playing Tetris. So here's where we're at right now. We have just finished chapter 8. Okay, we've just finished chapter 8. Chapter 8 was all about graphing quadratics. Graphing quadratics. Chapter 9 is all about solving quadratics. We have graphing quadratics, and now we have solving quadratics. Chapter 9, we are going to spend an entire chapter dedicated to solving quadratics. We've got sections 9.2, 9.3, 9.4, and 9.5 to do in chapter 9. We're going to do 9.2 and 9.3, have a quiz. We're going to do 9.4 and 9.5 and have a quiz. Okay? 2 sections quiz, 2 sections quiz. Now, let me remind you that next week starts the late start days for testing. Okay? Next week is the English tests. Remember that it's a late start days on the Tuesday, Wednesday. It's a special late start. It's a 3-hour delay. I'm not going to take the time explaining that. You ask your mentor teachers about that. The week after that is the history tests. Stop doing whatever you're doing. The week after that is the U.S. history tests. The week after that is the algebra tests. Okay? Now, so that basically means we have about 3 weeks until the algebra test. We are just going to be getting done with chapter 9, and then we have one thing to cover in terms of probability and statistics. And then after that, we're going to be doing some review tests. Okay, basically taking the old released versions of the state tests to see how we do and to show you the types of questions that we've been covering. Now, we've been reviewing all along, all these checkpoints, all of those things that we've been doing. Those all are state test questions. So we have been reviewing as we've been going. It's going to take a little bit to remind ourselves of things right before the state test, and that's what we'll do those days leading directly up to the state test question.
Didn't we only have the one state test this year?
Yeah, if you're a freshman, then yeah, you only have one state test algebra 1. Now, so let's talk about these couple sections that we have. It's all about solving quadratics. Now, let me remind you that for the state test, every single question, you have the option of bringing open a window using the Desmos calculator. Okay? You have every single question. It's not like middle school or tests before where the calculator was only active on certain questions. That's not true anymore. You have the Desmos calculator available to you every single question. So I'm going to teach you today several types of questions that you can answer using the Desmos calculator. Now, throughout the rest of this chapter, we're going to find more algebraic ways. This is what I'm teaching you today is using Desmos to solve all of these things that over the next couple of weeks, we'll use algebraic methods. Like today we're using Desmos. Tomorrow we're going to get into solving by square roots to solve quadratics. And then section 9.3, that is section 9.3, then section 9.4 is this thing called completing the square. And then section 9.5 is this thing called the quadratic formula. All basically focused on how do you solve quadratic equations and quadratic functions. All right? So let's take a look here. And I'm going to ask you guys, where do you look to find a zero of a function? This was on your quiz. Where do you look to find the zero of a quadratic? Where do you look? Because we had some key points that we had to identify on a quadratic.
The x-intercept?
The x-intercept, exactly. So if I'm looking at this quadratic on my screen, oh, I'm sorry, I didn't even pass out the guided notes for you. I was going to say you could fill in the blank, but didn't need a blank to fill in. We're going to talk about zeros of functions, right? We've had this before. This is nothing new. A zero of a function is just basically an x-intercept of a graph. A zero of a function is basically an x-intercept of a graph. It's whatever I can plug in for x to make the equation come out to be zero. It's whatever I can plug in for x to make the output equal to zero. That's really what we're looking at for a zero of a function. Now, zeros of a function is not just something that's unique to quadratics. Zeros of a function could be any type of function. And then you're just looking at all the multiple places where I could plug in and find x to plug in to make it come out to be zero. Now, so you have your blank there. It says, remember that a zero of a function, this is actually the exact slide. I pulled the exact slide from section 8.1, chapter 8, section 1. And we said, okay, the two zeros of this function are the x-intercepts. So looking here, it looks like it's positive 1 and negative 3. Looks like positive 1 and negative 3 will look like those would be my zeros of my function. We are going to spend an entire chapter dedicated to finding those coordinates. We are going to spend an entire chapter dedicated to finding those coordinates. That's what we're going to be focused on in this chapter 9. Okay? So let's start by using Desmos to find. Let's start by using Desmos to find those values. So, if you wouldn't mind, please go into desmos.com/calculator or just Googling Desmos and clicking on the graphing calculator, not the scientific. I'm going to get these out of the way, these out of the way, get this out of the way, get this out of the way. There. Get out. I don't need this calculator. Got to clean up my desktop a little bit. Okay, here we go. All right. So let me just pull it open as if it was a new tab. Desmos.com/calculator. That's what you want to go to. Desmos.com/calculator. This is what it should look like. So yes, every single question, you have a button that says a little calculator looking button. And if you click on that button, a separate screen will pop up with this exact looking graph. So let's plug in example A. F of x is equal to x squared plus 4x minus 12. Do I need the f of x equals? No. X squared. How do I do the squared? Shift 6. Good. And then I can just keep typing plus 4x minus 12. Zoom out a little bit. So where am I going to click? I want everybody doing this. This is not I'm just going to sit and watch day. No, because I would hate for you to get to the end of this lesson and still not know how to plug something in using Desmos. I will tell you right now, unless otherwise told to do a different method, I want you every single time on the state test to find the zeros of a quadratic. I want you using Desmos. Because I'm going to tell you right now, the other methods are much more difficult. Okay? I want you using your computer method. Question?
My computer's out right
I think I should have an extra one. There was one that was plugged in over there. Okay. So where do I click to find the zeros of the function?
Intercepts?
Yeah, so I'm going to go, boom, here. Come on. -6, +2. Okay, I'm going to screen capture that in, just so I can save the notes. Save to current page. Now, what are my answers here? Well, my answers are the x values, right? So I'm going to say x, and I'm going to say x equals -6, and x equals +2. Could I write the full coordinate? Maybe. It depends on like the box on the state test. Like if it gives you the option of putting it in a full coordinate, put it in a full coordinate. But if it just says x equals, then obviously you just write the x value. Okay? If there's just one box and it doesn't say x equals, just write the x value. The y value is not really the important part. The important part are where the x values occur. Okay? Questions on that? Okay, let's do B. Let's do example B. Looks like I've got 2x squared plus 7x minus 4. Okay. This is what it should look like, folks. 2x squared plus 7x minus 4. So what are my two zeros?
-4, 0, and 0.5.
Yeah. Now, in all honesty, guys, I struggle with showing you this right now. Like, I'm really torn about showing you how to use Desmos to find zeros right now. Because the next three sections, section 9.3, 9.4, 9.5, require you to do this in a more algebraic method. Okay, depending on whatever it may be. So I struggle with showing you the technology because I need you to appreciate how much work this is actually saving you. Like, we will do this problem later on this week, and it will take us about 4 or 5 minutes just to do this problem, where all you need to do is pop it in Desmos, solve. So why are we doing the other algebraic methods? Well, because the state test requires us to. And there are questions that ask us like, okay, what's the next step? Or what would I do here? Or show me this, or show me that. Where it's not just, boom, spit out the answer. Okay? So that's the reason why we're kind of showing you these things. So my two solutions are x equals -4 and x equals 0.5. Let's do example C. Go ahead and plug in example C. And again, I want everybody plugging each of these in every single time we do them. I need it to be repetition. I'm not saying, I'm going to show you this once and you know how to do it forever. No, I need it to be muscle memory. I need you to be plugging these things in every time so that it's a habit. You know exactly what to do. Minus 2x plus 9. All right, so what happens if it comes out to be a messy number? Well, just round it. No big deal. If it's a word problem, tendency is that it's going to come out to be a messy number. And yes, we will work with a lot of word problems in this chapter. Tendency is it's going to come out to be a messy number if it's a word problem. So like for this case, I'm going to say x equals -2 point, well, if I would round that, I could say 0.097. I would say most of the time it's going to be best to round it to the nearest hundred. And actually, if I do that, the 7 is going to kick the 9 up to a 10. So it would actually look like that, -2.1. The other one would be x equals 1.43. Question.
How come the 100?
I don't know. Sometimes that's just what I prefer. It's pretty exact enough,
Okay.
usually. Honestly, 10th is probably fine too, but I'd say 100 just to be a little bit more safe. But unless otherwise noted by the test. Like that's my disclaimer here. You know, the state test might say, okay, round this to the nearest 1,000. Okay, then you got to go 3 places out. You know, or round it to the nearest 10th. Okay, then I don't have to go all the way out to the 100th. All right, last one here for this type. Example D. Go ahead and plug this one in. We got negative 0.5 x squared plus 2x minus 3. So what is my answer for something like this?
No solution.
No solutions, right. No solutions. If it does not go through the x-axis, there are no solutions to that. And we're going to see algebraically when that's going to happen. But for our purposes here, we just know that it's going to be no solutions because it does not cross the x-axis. Okay. Questions about that? All right, so that's our first, way of how the problems could be presented to us, where it's giving us the equation and asking us to find the zeros. Okay, that's not too bad. Throw it in Desmos, find the x-intercepts, done. Okay. Now, another type of problem that we could be asked is to solve an equation. Look down at the rest of this front page. Not writing these down.
There were like problems for these.
Okay. This is what I'm talking about. The answers are the x-intercepts, right?
Mhm.
So that's what you should be writing down. We're not just doing this for fun here. Okay?
Yeah, I understand, but like, it's just like hard to tell like what to write down for like
The x values. The x values. Just like I wrote it down. Okay. All right. So take a look here. Another type of problem that I could be asked is to solve an equation using Desmos. Or solve an equation using any method, but we're going to use Desmos because honestly, Desmos is always the easiest option. Now, how do we solve an equation? Here are the 2 steps. You graph each side of the equation, because you're going to have a left side and a right side. You graph each side of the equation as its own piece in Desmos, as its own equation, in the form y equals that side of the equation. The next thing is you look for the intersection points. You look for the points of intersection. And this I want you to underline or star or do whatever you need to do. The x values are what I'm looking for. The x values are what I want. Do I care about the y value? Not necessarily. But the x values are what the most important piece are. Okay? The y values, not so much. The x values are what I want. So let's take a look at example A. Take a look at this equation. X squared plus 2x equals 3. So what am I really solving here? I'm saying, what x value could I plug in here and here to make it come out to be 3? Honestly, we did this with linear equations too. We just used PEMDAS, right? And we just got everything over to the other side. Reverse order of operations. Done. Here, I can't do that because I've got 2 different x values. And it's like, where do we go? I can't combine like terms. What do I do? That's really all of chapter 9. What do I do? Our first method is use Desmos. Here's how we do that. We throw in the left side as one of our functions. So we've got x squared plus 2x. Throw in the right side as the other. Now, when it's a constant, do you notice how this is a 3 on the right side? It's just a 3. What you have to do is say y equals 3. Like if you just, I guess I should say this. Oh, shoot. if I just said 3, do I see anything pop up on my graph? No. It's not even recognizing it as a function. It's just recognizing it as a number. So to recognize it as a function, you need to say y equals 3. Now do I see it pop up on my graph? Yes. Where do I click on? Where do I click on? Where do I click? Noah? Where they intersect. Where they intersect.
So if I see red full coordinates.
Okay, now, what did I have you underline?
Oh, the X value.
So my answers are x equals -3, x equals +1. So what does that mean? That means that if I plug in -3 into the left side, guess what happens to the right side? Or guess what happens? It matches the right side. Like -3 squared is +9, plus 2 times -3 is -6. 9 plus -6, +3. So that must mean that if I plug in 1, it also gets me 3. Yeah. 1 squared is 1, plus 2 is 3. I found 2 x values that make this equation true. I really, we're going to get to a problem like this a little bit later on this week and next week, and this is going to take us a lot longer. I really hope you appreciate the process that this is the time that this is saving you. If this problem is presented to you in the test, I want you using Desmos. But the problem is they say, okay, use factoring or use the quadratic formula or use a different method to solve. Yeah, question.
So what exactly did you type down until the second half?
I typed in y equals 3. Does that make sense? Yeah. Okay, let's do example B. Looks like I have x squared plus 2x still, and instead of y is equal to 3, I say y is equal to 8. Okay, there they are. Here are my intersection points. See, it's a really simple process. You just got to know the process. X equals -4. Sorry, my equal signs tend to run together when I'm not plugged in. And x equals 2. Do I care about the y value that this is happening at? No. All I care about are the x values that these are happening at. Do examples C and D on your own. Yeah. Because I'm going to walk around and just ask you if you got any questions. Oh, you know what? I probably should have done C with you. Because C's weirder. You know what? Let's do C real quick. Well, let me show you. It was x squared minus 8x. I forgot this one comes out like this. -16. It only hits once. It only hits once. See where it hits down here? Let me screen capture that in to my notes. Ooh, where'd you go? There we go. See, if it ever comes out, see what point is that line hitting this quadratic on? What is that point called in terms of the quadratic? It's on its vertex, right? So it's actually meeting it at its vertex. So we had 2 solutions for one of them. This is actually just one solution. So x equals just 4. Do I care about the -16? No. I don't care about the -16. Okay, do D, I guess. Go ahead and do D. I just want to make sure we're all plugging these things in now, okay? I appreciate you actually doing it. And you know what? If you think you got it, do E and F as well. Graph E and F. See if you can figure it out. All right, so let's take a look at D. I'm going to go ahead and throw this into Desmos real quick. We've got x squared plus 4x. Oops, x squared plus 4x. And on the bottom, I've got y equals -4. All right, this is another one of those ones that just come out as 1 point. So here's D. And so my solution is x equals -2. Right? Questions on D? Okay, let's take a look at E. Now this one's kind of weird because on the left side we've got a full function, -x squared. And on the right side we have another full function. We don't even need the y equals anymore for E, 2x plus 4. Now, what happens here? Do they cross? So it's no solutions. Remember, if they do not cross, it is no solutions. Make that a little bit smaller here. And again, we would write no solutions. Not bad with a mouse there. No solutions. All right, let's take a look at F. Looks like we've got -x squared. I'll do plus 4x here. And it looks like I need to add back in that y equals. I have to throw it in the box there. Y equals -4. And I have two solutions here. Two solutions. Let's see where they are. Yeah. You know what? I pointed to the wrong thing. There's the. So my two solutions are, looks like x equals -0.83. X equals -0.83. And x equals 4.83. Questions about that? How do we do on those? Pretty easy, right? Pretty simple? At least the process is simple. Okay, flip it over onto the back. Now, I will say to you guys that we're going to do a lot of word problems in this chapter. Okay? A lot of word problems. Why? Because one of the main things that we can talk about in terms of application is projectile motion. Now, what is projectile motion? I think I talked about it in here. Anytime you throw or toss or kick or whatever, anything off the ground, the acceleration due to gravity is constantly pulling it back down again, right? So that means that it's constantly going to make it pull down to the earth, which means that the shape that anything makes after it gets pulled to the ground is this parabolic shape. Like, for example, okay, you ready? I'm going to toss this to you. You ready? Everybody follow the shape of the marker that it makes through the air, okay?
Oh, we went over this.
We did this, right?
Yeah.
Now toss it back to me.
Everything's parabolic.
Every throw is parabolic. Every throw is a parabola. No matter what we throw, no matter how we throw it, no matter how fast we throw it, it's always going to be in that parabolic shape. So what we can do is use our methods to find out important pieces, like when does it reach its highest point? What is its highest point? When will it hit the ground again? When will it hit certain feet in the air, depending? Let's take a look at that. Take a look at our next problem here that we have on the top of the back page. A football player kicks a football 2 feet above the ground with initial vertical velocity of 75 feet per second. The function h is equal to negative 16t squared plus 75t plus 2 represents the height h in feet of the football after t seconds. Now, our job is not to create that equation this year. Our job is to solve that equation, but not create that equation. That's Algebra 2 and beyond in like physics and stuff.
Okay, so I looked this up.
Okay, so queso is a kind of cheese.
Okay.
Queso.
If you throw a ball at 109 miles an hour, the
Yeah.
ball will always stay straight for 60 feet. So is that still
Not necessarily.
Unless it's caught.
No.
Which is caught.
Yeah, it's
Now we are right, but it's still being pulled down. It's still being pulled down.
It'd be so fast that it's straight.
But it's still being pulled down.
By gravity, yeah.
Right.
But it's not moving.
As our eyes see it. It's not moving enough that we can tell a difference. Right. Is it still a fraction of a decimal, like a really, really, really small amount? Of course, but yeah. All right, so let's do this. Let's plug in that equation into Desmos and see what happens. So we got negatives. Everybody do this with me. I'm going to replace the t's with x's. Negative 16x squared plus 75x plus 2. So here is the football. Here is the path of the football. Looks like it's been kicked, goes high up in the air, and then comes down again. Now, my first question says, after how many seconds will the football reach 50 feet above the ground? Now, could you trace along this thing and see, okay, when is it going to reach 50 and kind of guesstimate where it's going to be? Yeah, but there's a better way. Go down to a new equation and write y equals 50. And these two places are where it's going to cross that 50 line. So it's going to be 50 feet at 0.77 seconds and 3.92 seconds. Okay, it's going to be 50 feet off the ground here and here. 0.77 seconds and 3.9 seconds. About. Okay, and all I did was plug in another 50, showing you the graph. This is what I did. I just plugged in y equals 50. And found the intersection.
Where are we going? Like under A?
Yeah. Negative 16x squared plus 75x plus 2, y equals 50. You're looking at the zeros. Scroll out. Scroll out. We will look at that in a second, though. All right. Now, the second question is, what is the maximum height of the football? Well, what point do I click on of the parabola to find the maximum height of the football? Not the range, the vertex. Click on the vertex of that parabola. That vertex is going to tell us max height. So that basically says that at 2.3 seconds, it's going to reach a maximum height of about 90 feet in the air. 89.9 feet in the air. That's the maximum height of the ball, the vertex of that parabola. When does it reach the ground again? Now, what am I going to click on to find when does it reach the ground again? The x-intercept. Right. And I'm really not even going to worry about the first x-intercept. I really only care about the second x-intercept, because that's when it's going to hit the ground at the very end. So how long does it take to reach the ground again? About 5 seconds, 4.7 seconds. Just by knowing the equation, I can tell a lot about the path of the ball. Okay. So when does the ball reach the ground again? 4.7 seconds. 4.7 seconds. All right. I'm running low on time, so I just want to cover a couple of these systems of equations at the end here. Systems of equations. Now, the last type of problem that I could present to you is a system of equations. Remember, we did this like way back in Christmas time. How do you find the solution to a system of equations? You're looking for where the two lines intersect. What if they're not lines? Doesn't matter. Where are you still looking? Where they intersect. See, we didn't know other types of equations back then. Now we do. So let's throw them into Desmos and see what happens. Let's take a look at example A. I'm just going to put each equation as its own thing. X squared plus x minus 1 and negative 2x plus 3. Zoom in here. And I'm going to click on my intersection points. Now, it depends on how the problem is asking you to provide the solution. Like, for example, for this one, I'm guessing that it would want the full coordinate. Sometimes it just wants the x value, but a lot of the times it's the full coordinate. So like for this one, it would be negative 4, 11, and 1, 1. Did I plug it in right? Negative x squared plus x minus 1, negative 2. You check what you plugged in.
I plugged in the exact same thing that you did.
Did you click on these points?
I don't even have those points.
You got some issues then.
I know. But I plugged it in just like you did.
Hold on. All right, let me see what's going on.
I need to use it for probably x squared plus x minus 1.
Oh, you got to zoom in, buddy. You're all the way out at 200.
Oh, that's fine. Thank you.
All right, let's take a look at another one. I'm actually going to jump to example E. X squared plus x plus 3 and 4 to the x. 4 to the x. So this is no longer a quadratic. This is actually a quadratic and an exponential. How many times does it cross? And there it is. See how easy that is in Desmos? Like, you haven't learned the algebraic methods yet, but people, I hope I can stress to you the importance of knowing this stuff because it's so nice. No, this wasn't even a thing. Desmos what?
Yeah, I know. How did they
Like we had to solve it algebraically. There was no other method. That was it. Yeah, but I would say always rely on your computer. So again, moral of the story is we're going to learn a couple different algebraic methods of solving these things, but rely on your computer the most.
actually listen to the calculator?
Yep. Let me